everyone here. Good morning, afternoon, evening. Greetings for all of you who have joined us from across the globe. We are very, very excited, to say the least, to be having all of you here today. Just a quick introduction. This is Kritika. I head marketing and I'm co-founder at KANDOLA NETWORK. We truly appreciate, like I said, your presence, for joining us today, especially to help KANDOLA NETWORK set course for mapping out a new landscape for the blockchain space. So your continuous support, your feedback, your critique, your questions, all of those things are going to be very much welcome. We in fact have a Q&A session that we're going to open up towards the end of the session today. So please feel free to offer us both your support, your feedback, your critique, etc. Anything and everything that you have on your mind. Please feel free to share with us during that section of today's session. This is, like I said, KANDOLA Network's very first event. And in case you don't know too much about KANDOLA Network already, in a single line, a quick recap would be that we're a privacy by design, decentralized layer 1 blockchain that enables fast messaging, data processing, and storage. And I think what we're most excited about is that, the application of our chain is going to be across, is domain agnostic, and it's going to be across multiple industries, and that truly allows, the opportunities to be limitless, well beyond what we currently are aware of. So we understand that the scale and the heights that we need to reach are significant, but the team on board here, who you will soon get to know through the course of this 1 hour, are very much up for the challenge. So since today is a historic event and it's our Testnet Prototype platform demo and the launch of a brand new shiny consensus algorithm, we're going to be launching that today. We have christened it the Proof of Real-Time Transfer, or we like to call it for short as PORT. We have a packed agenda ahead of us where we will be covering important topics, the introduction of PORT, the overall architecture, the deployment, the demo, all of that fun stuff. But a few quick admin items before we jump into team introductions and sort of jumping into the main agenda of today's call. We request everyone to kindly stay muted throughout the entire period of the call. It would be great if you could go off video as well as stay muted so that we conserve bandwidth for today's meeting, and so all of you can really get to know the team much better as well. Please populate the chat screen with your feedback, your questions through the course of today's session. We will be constantly monitoring it, and then we'll bring up quite a few of them towards the end of the session as well. Feel free to keep the chat box alive. And make sure that you do raise hand when we open it up for FAQs. So those are a few quick admin items. We'll talk about the most exciting part, which is also the NFT giveaways towards the end of the session. So stay tuned for that. And without much ado, I'm going to be handing it over for our, to kickstart this session today. I'm going to be handing it over to our Chief Technology Officer, the brains and the ideator behind a lot of today's demo deployment session. I'm going to be handing it over to Gul to take it over for his round of introductions. So we're going to do team introductions first.
That's a great introduction, Kruti. Thank you so much. I hope all of us have fun today, and I'm very, very thankful for everybody joining us. But I would like to go on one round of introduction for the team quickly, if you don't mind. I am Gul, the Chief Technology Officer. I like to call myself the head geek in KANDOLA. And I have a couple of masters from BITS Pilani, an Ivy League engineering school in India, and I've taught there in the computer science department at Pilani, and I've had close to 17 years of experience in the fintech world before joining KANDOLA. I'm very proud to say I'm the first employee of KANDOLA after the co-founders. Go. Who's next? Shruti, who wants to go next? Nara?
Yes. Nara. I'm the head of research. We solve all the cutting edge problems there are in building a layer 1 blockchain for the applications of general purpose transactions. We have a strong team here, and you're going to have to improve.
Thank you, Nara. Who goes next?
I'll go next.
Hey, I'll go next. Hey, this is Sriram. I'm one of the co-founders for KANDOLA. I look after the operations of the company, so I'm responsible for the day-to-day operations. I have a master's from IIM Bangalore and a Bachelor of Technology in Electronics. I have a couple of more than 20 years of experience in the IT and software and stuff like that. Again, welcome all, and hope we have a lot of fun, a lot of questions, a lot of ideas exchange. Thanks. Sid, you want to go next, or Manish? What?
Who goes? I'll go at the end.
All right, Manish.
I'm Fanish. I work as an architect at KANDOLA. I work with Gul on solving a couple of things and getting all the network things going. Having a lot of fun, to say the least. After solving some of the toughest problems out there, it's absolute fun. Really excited to show what we have done all this while.
Super. We've got Shruti next.
Hi everybody, Shruti Datta here. I'm part of the content and marketing team, and I'm your go-to person if you have any issues with the community engagement. My day-to-day efforts involve creating little bite-sized pieces for the community to understand the cool and the fabulous geeky stuff that our tech team is doing. So next, I think I'll hand it over to Abhishek.
Yeah. Hey everyone, Abhishek here. I'm the designer for the KANDOLA. You can see over here, KANDOLA.
Awesome.
I do the graphics, videos, and everything. You can watch our video at YouTube and follow us on all the social media to see the graphics. And hope you have a fun day today at the launch. Now I'll hand it over to Smita.
Hello everyone, this is Smita here. I'm part of the marketing team, and I had been helping them a little bit of market research and also writing content where we showcase how KANDOLA can be used for a multitude of industry application. So welcome again, and hope you enjoy this event. And with this, I'm going to give the stage to Siddharth Banerjee, who is the CEO of KANDOLA, and he'll give his introduction himself. Over to you, Siddharth.
Thank you, Smita. Hey everyone, it's a very important day for us. I'm Siddharth. I am the founder of KANDOLA, computer science engineer. This is my third startup, so I've been in the circuit for a while. I've known the ups and downs of the startup life, if you call it. But a completely different experience here, and we're very excited to be able to bring what we have right now, which is PORT, the new consensus algorithm, and the backbone, which is the implementation of how this entire system works out. I hope everybody has a great time. This is going to be a fun event. We're going to keep it very informal, as I guess you have already figured out. And then Gul is having his coffee. All right, so over to you, over to Kriti or Gul, whoever wants to take this forward. But before that, a quick go, no go. Gul, I know we were fiddling with the code. Go from tech.
Absolutely, I think it should work. We've put in a lot of effort, and hopefully, with some confidence, let's go forward. And if we fail, we fail forward.
Awesome. So it's a go from tech. Kriti, go from marketing. We have infrastructure, everything else.
Yes. So wait, hang on a second. So from a marketing, I was just going to say again, quick admin. Anyone who's not part of the core KANDOLA team would be great if you could go off video, go on mute. We'll call out anyone who has questions later on in the event. And apart from that, it's full steam ahead, go from me.
Awesome.
Let's go. So,
all right, go to the moon. Over to you.
Yeah, it is going to be it's going to be extremely difficult for me to place this in context for the lovely audience, people who've taken interest in Kandola and joined us to see what we're doing. It'll be extremely difficult for me to explain to all of you, the varied audience that we have here, without setting some context. So fundamentally, the perspective of, say, today's layer one blockchains have been, if I can simplify it, right, if I can oversimplify it, is sending cryptocurrency from an address to an address, right? All of the transactions that you see in almost every blockchain today, I can say almost all of the transactions, because there are other transactions other than financial transactions that go through from to an address, right? But it is cryptocurrency that is exchanged in today's blockchain, in today's blockchain world between addresses. When we looked at it, we said, if we had to get blockchain to the masses, to the billions, like we purport to do, right? The first hurdle that we have to overcome is to have breadth across industries. We cannot tackle sending just cryptocurrency from an address to an address. We have to send an abstract message from an address to an address. And that message itself is an unopinionated payload. So you can have absolutely anything in that message. You could have a financial transaction, which is status quo with most blockchains. You could have health information. You could have IoT information in that message payload, right? So if we take that paradigm or that lens, then you get to a point where blockchain can have the breadth across industries, across use cases. It can reach the masses, right? And so that is one. Keep that at the back of your mind while we speak and get deeper and deeper during the session. And the second context that I'd like to establish in your minds today is that if Web 2 as it stands today, right? Or let me put it this way: Web 2 as it stands today has commoditized instantaneous experiences. Right, so you go to Gmail, you go to any experience, you go to Facebook, you go to Instagram, you go to even a very on-premise kind of an application, right? Phone Pay for that matter. The experiences are instantaneous, right? At least the experience is instantaneous, right? Even if the transaction is not instantaneous. And that means that for Web3 to be able to cross that chasm and reach the masses, the only way out is for Web3 to beat that scale, right? As a commodity, and not just beat the scale and say, okay, we can do so many transactions per second, but be able to beat Web2 at it, right? So keep these two in mind, because these were our driving North Stars to ensure that we can take blockchain to the masses across industries. We needed to make sure the message has to be agnostic. The message has to be unopinionated, not specific to an industry or a vertical. And the fact that we have to scale to potentially millions of transactions per second, millions of messages per second in a decentralized fashion, in a truly decentralized fashion, let me put it that way, to be able to make Web3 a success, right? So keep that context in mind. I hope these two contexts kind of set the ground for the rest of the session. If you have any questions, any thoughts, please feel free to use the chat. Shruti and Kriti and the marketing team are keeping an eye out for your questions, and we'll handle questions in the end. So to achieve this goal, we came up with an algorithm. We published a paper, and we had a bunch of peer reviews done, and I thank the professors who are here who've done the peer reviews of the algorithm itself. And the algorithm, as Siddharth and Kriti mentioned, is called proof of real-time transfer. And let me share my screen and run you through the big picture of I'm sorry for, are you guys able to see my screen? I'm sorry for you seeing the logs. Yeah? You're able to see my screen? Can somebody confirm? Yes?
Yes.
Yes.
All right. Thank you so much. So an overview of this paper. You can find this paper on the website. You can, I'm sure a lot of you keen folks have had the opportunity to look at the paper. I know it is a bit heavy, but a quick overview is also there in the website, and I'm using that to run you through quickly why we want, or what we're doing in terms of the algorithm itself, right, and how it connects to the context that I set. I'll skip a few slides here. Obviously, why decentralization? We want to ensure that people own the nodes, right? People own their data, and there is absolute end-to-end privacy, and that there is no single point of failure anywhere. And obviously, the standard for decentralization today is the blockchain, right? And we spoke about data ownership. So I'm going to skip through a few slides here just to make sure that I can walk you through the protocol itself. So because the nodes are decentralized in a decentralized platform, obviously, we have the decentralized nodes have to come to a consensus, and there is a protocol to come to consensus. Because we're dealing with abstract messages, we are assuming there are three entities in the system, right? A producer who can send messages, abstract messages, a consumer who wants to receive the messages, the from address and the to address. And we have the decentralized port nodes, the nodes that sit in between, that are running potentially on commodity hardware and are completely decentralized. Right? The goal of the port nodes is to take messages from the producer to the consumer, and in the process be able to verify the integrity of the message, verify the authenticity of the message, and verify the confidentiality of the message. So these three parameters are the fundamentals of reaching consensus. So every decentralized node would, in parallel, when receiving a message, would verify that the sender is accurate, the destination is accurate, that the message hasn't been tampered in transit, and that the message is confidential. They can't see the message, obviously. Even the network can't read the message. Right? Now, to make this happen and for the nodes to reach consensus, there are multiple components in the system that play a role to ensure that we can reach the scale, the second in the context, right? One of the key entities is the decentralized identity management. Every producer, every consumer, every node in the network would have a decentralized ID called DID, and the DID is a W3C spec, and we have implemented, as part of the launch, we have implemented a DID registry, which is not decentralized at the moment, but we'll be working forward to decentralize the DID registry. Now, what the DID registry gives you is every entity in the system would have a unique identifier. Usually, it'll be a URI that starts with the DID : and a method, a DID method, and then the address itself. Now, this will uniquely identify all of the participants, and not only that, it will also provide the participants verifiable credentials. And what that means is, I keep giving this example to the team. You go to the bar, you have to prove that you're an adult to drink. You have to show your driver's license, or you got to prove that you're an adult, right? That is a verifiable credential. Now, DID does it in a zero knowledge proof mechanism, so that you don't really have to show your driver's license, but the verifiable credentials associated to your identity will automatically prove that you're an adult, right? In our case, in the consensus algorithm, the DID serves to prove that the message sender is authentic, the message destination is authentic. Every node in the decentralized network, whenever it sends messages to a peer node, the peer node can authenticate, can verify that it is indeed node 1 that sent it to node 2, right? And so the verifiability increases with the DID registry. So the message structure, as I mentioned, we should be able to be sending abstract messages, but we do have a protocol, a structure to the message. And if you look at the right-hand side, it's a copy-paste snippet of the white paper from the white paper itself. This is the structure of the message. The message is a header and a body. The body is encrypted end to end. Even the network nodes cannot decrypt it, cannot see what is in the payload. The structure is pretty straightforward. It has an ID, it has a from address, to address. We spoke about it, and it has a bunch of leaders and acknowledgements for the producers. When the producers send the messages, we can acknowledge back, and so on and so forth. I don't want to dive too much into the details of this in this call, because we surely will be running out of time to show you the system itself. So essentially, the producer creates a message. We have an uplink SDK that will help systems to easily comply with the message standard, the KANDOLA message standard. And then the actual nodes verifying the messages, as I mentioned, very simple, yet powerful consensus verification. As I mentioned, valid source, valid target. If you look at the pseudocode on the right, is it an authorized target? Verify the signature of the sender. It really, the consensus protocol really doesn't look in the payload. As I mentioned, the payload is not visible to the nodes at all. So what is the song and dance that happens that happens between the nodes in the network? Is truly the algorithm itself, the heart of the algorithm. Each node would get all of the messages for verifiability. If a leader node that is marked as a leader for a particular message receives a message, it will forward it back to other nodes in the network. So there is complete verifiability of all of the messages in the network. And then once the messages reach a limit as to a configuration, again, not going into the details there, messages will be batched into one rubber-banded batch, if you will, right? Put a bunch of messages in a batch, and to make sure that no malicious node, no Byzantine node is freeloading, we insert control messages. Each node will insert control messages and create what we call a batch derivative to ensure that every node that is verifying a batch of messages verifies it without freeloading, verifies it without Byzantine behavior. So every node will verify that the valid messages are filtered out of the control messages, and thereby there is an airtight system. By the time all of the nodes verify the batch, take the control messages out and say these are the valid messages, everybody can come to consensus on what are the valid messages. Now the beauty is that this happens instantaneously, real time, because of the simplicity of the verification of the messages and the fact that we can concurrently verify messages even in a batch, right? Even in this batch, we can concurrently verify, utilize all of the compute power. We don't need a GPU. We tested this with CPUs and reached very high throughputs, upwards of 150K messages per second can be verified and reached consensus on commodity hardware. All right, and this diagram kind of shows you the picture of how the batches propagate, the batch derivative propagates through the network to reach consensus, and how we have ensured that all, or at least all of the attacks that we identified as possible Byzantine attacks are covered or addressed in this protocol. For example, the path in which the batch derivatives flow through would be decided by a verifiable random function, and each party in the network can verify that it is indeed random, right? So the path that the batch derivative takes is also verifiably random. That thwarts attacks where two nodes can collude with each other and so on and so forth. Right? So I'll stop there for a moment, and again, I'll give you a breather to ask any questions on the chat. Please feel free to use the chat. I will put it out there for Siddharth or Nara or Sriram. Anybody to comment? Anything that you want to add to what I mentioned? I know we're running out of time, right? That much is sure. Fantastic. So
in this case, I wanted to add a small element here. We've all seen email applications. We've all seen applications which help you do messaging. We've seen applications with IoT. All those are happening today in a centralized world. What will it take for us to keep them running in a fully decentralized environment? So without any central player which comes and tells you saying, trust me for the service I'm providing, is there an environment that we can build which will help you communicate with any entity in the world? So that's what we are building right now, and the upcoming demo will give you a lot more information about how this is being built.
Perfect. Thank you so much, Nara and Sid. So for want of time, let me proceed further. So for the launch of the prototype, and this is the first step of many that we'll be taking to reach testnet and then mainnet with this generic message transfer protocol, if you will, right? When we designed the prototype, we started with a benchmark. After the paper was published and we got peer reviews from wonderful people, we started working on benchmarking, and then we said with a small team we should build a prototype to prove that the protocol would work. And the approach we took was to ensure that we can handle millions of messages almost at real time. So we came up with an architecture for the prototype that would include elements that can scale to millions of messages, millions of transactions, millions of messages per second. I would love for Fanish, our chief architect, to talk to the architecture of the prototype. Fanish, you want to take over?
Hey, thanks, Gul. One of the fundamental elements that we had extreme design focus on, as Gul mentioned, was the scalability of the entire network itself. If you kind of look around, most of the networks today, are require special hardware in many cases, or in many cases, GPUs, or even customized ASIC, etc. platforms to get any practical usage of the protocol or the network itself. So the idea was to break that down and make sure that this network becomes accessible and kind of deployable on commodity hardware, but with extremely good performance, and not to forget the real-time or near real-time latencies that we can achieve to get the kind of practical usages rolled out to many segments. So the architecture itself that we zeroed in on was very unconventional for blockchain everyone network. The primary focus was on multiple things. First, of course, is scalability, and it has to run on commodity hardware. But beyond that, observability, right? One of the other things that we actually saw that is not very transparent as well as not very accessible is the observability tools that are available with any of these networks that are available. What's the kind of resource usage that you have, what's the path in your system or network that a particular message is taking, etc. Right? So what we realized is we have to bake in all this observability and other tooling as part of the network components itself, so that nobody needs to kind of add on or use external tools, which always is an afterthought if you look at it that way, to monitor and meter your network and to extract the best out of what you have. So we actually built it on that philosophy. So everything is asymmetrically scalable. If you look at any component out there for any networks, it's all symmetric scaling. If you want more throughputs, you just go on deploying the same instance of that network component over a large farm or a large infrastructure to get better throughputs, right? But since we actually realized symmetric scaling is not the best use of compute resources, we decided to kind of make it completely asymmetric by breaking down the entire node components into sub-components based on the role that it performs in the system path, right? For example, the compute nodes can be deployed on compute heavy infrastructure or compute tuned infrastructure with more cores, etc. But if you decouple that with blockchain persistence, which is for storage, it doesn't require those many CPUs, but it requires fast, like disk or fast storage elements. So you can actually deploy that on that kind of hardware, like to get the best out of what you have. So you are freeing up most of the compute as well as IO from each other and making sure that you get the best out of everything. The idea is to saturate or optimally use whatever resources that are available at that point in time. And we also packaged the whole stack as containers because that's possibly the most commodity packaging system out there, instead of depending on a lot of external libraries like kernel versions and etc., and also to deal with all the operating system nuances with drivers and etc. So we said we will package everything as a container so that anyone for that matter can just bring the stack up with minimal or zero configuration. So that is the whole thought process behind the architecture. Over to you, Gul.
Thank you so much, Manish. I'm struggling to handle all of the windows very clearly. That is a great overview of the architecture, but to go into a bit of detail and share the launch itself, the demo that is working itself, let me share my screen again. Let me know if you can see my screen. Yeah. As Manish mentioned, we thought of scalability at every inch of every line of code that we have written so far in terms of the prototype. All of this is right now hosted on AWS, each of the containers. So we are using the Elastic Container Service just for this prototype, just to demonstrate that this works in containers, as Manish mentioned. So if you look at what I'm showing you now, I'm going into one of the ECS clusters, the container registry clusters, and you'll see a bunch of nodes running here. But what is interesting for us is that there are three decentralized nodes, right? One is this one is this one, and one is this one, running independent of each other and running the architecture for a Kandola node. And what does the architecture for a Kandola node have? These are full nodes. So they have the consensus node inbuilt as a Docker container. It has the storage node built in as a Docker container, easily pluggable. You can decide that you're only a validator and be just a consensus node and not have the storage with you, and so on and so forth. So you will see three consensus nodes right here. And we are going to generate producers. We're going to simulate producers from a message generator that we built again as part of this prototype demo. So I'm going to log into this message generator and quickly send some messages so you can see the messages flow through. I'll show you the messages, I promise you.
Here, this is a very critical part of our demo. And the launch.
Forgive me for using pseudo rights. Okay, so you see a bunch of containers are running on this instance. I'm going to log into the message generator. Nothing fancy. I've just logged into the message generator, and we use, for everything, we've used cutting edge, given the choices that our chief architect Fanish made. So I blame Fanish for all the choices, but each of the choices are uber scalable. So for now, what I'm going to do is I'm going to generate a sample message using a simple API call to the generator, which says, if you can see this right, I don't know if you can see this right. I'm making a simple call to the generator API. The generator is not part of the product itself. It'll be eventually part of the uplink. Here I'm generating 501 messages with the payload of 20 bytes each. These are abstract payloads that are encrypted automatically according to the protocol. And these generators essentially generate messages that are valid Kandola network messages. So I'm gonna generate them, and I'm going to show you a portion of the message. So I put them in temp messages.json. So I'm going to say head minus maybe 20 of this sample file that I generated. Now, remember, we've still not sent these messages yet. We've just generated the messages, sample messages that we can send. So if you look at the sample structure here, it follows the Kandola schema. It has all of the attributes that I mentioned. It has a leader that is set. And all of these are DID addresses, right? If you see these addresses, it is coming from a DID address. In this case, it is DID colon CAN-P. CAN-P stands for the Kandola producer method, and DID colon CAN-C method stands for the consumer method. And DID colon CAN are Kandola nodes. So the leader that the producer has selected is one of the Kandola nodes out of the 3 nodes. And it is coming from a producer to a consumer that is there in the DID registry. Now, where is the DID registry? The DID registry right now, as I mentioned, is centralized, and we're using console for the DID registry. The DID registry also acts behind the scenes as the node registry. So you will see all of the services offered by the nodes. Each of these are nodes, and each of them you can see it's a CAN method. That means it's a Kandola network node that is identified in the node registry. And you will see that each node exposes multiple protocols. Not only have we containerized it, but we've made sure that each of these nodes can talk to each other using gRPC, REST, or 0MQ, right? Which has asynchronous I/O, which is the fastest for internode communication as technology stands today. And we also, as I mentioned, this is the node registry, and the DID registry is also stored as key value pairs in console. And you can see that the DID structure is hierarchical, at least the way it is stored at the moment. You can see 3 nodes that are independent, and there can DID IDs, and you'll also see hundreds of producers and hundreds of consumers, right, in the DID registry. Now, let me come back if I can hunt down the message generator. Okay, so what we've done so far is generated the message. Now I'm going to use GHC to push the message out to the leader. Now, before I show you that, because the moment I do that, it's going to go into sending hundreds of messages at the same time into the network, right? So what I'm going to do is I'm going to, for the sake of this, I want to be able to send it to the leader. So I'm going to just check if this DID belongs to a leader at the moment, F25C. So F25C, let's go see F25C here. F25C is right here, right? So we see the DID, and we also see that F25C is ending in F25C rather. Is also up and alive. All of the service checks, all the health checks for that node is working fine, right? All right. So so now that is clear. The nodes are up and running. I'm going to generate the messages. Are you guys ready?
Yes.
Before I send the messages out, it is better if I show you a very rudimentary UI that is very much in line with Etherscan. That will show all the blocks that are created. I want to hit this URL and show you that this is right now empty, right? It is a rudimentary UI. Both the producer, you can assume the UI is a consumer, like Etherscan, that shows you all the blocks that are generated in the blockchain. But the producer is rudimentary. It is just a client that is sending messages. The consumer, this UI is very rudimentary. So forgive us for that. We don't have time to beautify the portions. But the network is solid. The network is working as expected. Okay, so it's blank now. I'm gonna hit it. I found this. Okay. Okay, I'm going to hit this, the leader machine with 501 messages with 1 concurrency. So that means 1 producer is sending instantaneously the 501 messages that we generated right here. Sent. And you will see here, by the time I come over to my consumer, the UI, you will see all of the blocks getting created. We are showing only 10 blocks at the moment. But you will see all of the blocks getting created. The batch size for the block is 100, and so each of these blocks have 100 messages. Each of the batches have 100 messages, and we were able to execute it instantaneously for 501 messages. And we have in our test right now, even though it is a prototype, it's our first step. Thank you so much. Yay!
This is historic. This is literally the first time that the whole team is coming together to see this. And to see it live, instantaneous, real time, 500, and soon, sort of touching massive theoretical limits. Go, keep going. This is amazing.
Oh yeah, and Fanish can talk to it. Fanish, you've tested up.
Can you go back?
This is something. This is an internal team meeting that we are broadcasting to the world and sharing with you how we're literally seeing this for the very first time. So,
hey, good. Can you go back to the screen, where you actually launched GHC?
Yeah, let's do it again.
Yeah. So, we actually chose GHC to actually, do this, kind of, test as well as a benchmark. If you look at it, right, we actually are running on a very, very thin infrastructure for this demo, and that too with just concurrency of one, we hit around 1330 messages per second, as you can see it in the summary, right? And the latencies are eye-watering to say the least. The fastest is sub-millisecond latency, and this is uncompressed over gRPC and running on an extremely thin infrastructure, right? And in our as in controlled benchmarks and etc., we have done close to million blocks with a batch size of 1,000. Do the math, right? Entire test ran through in less than 47 seconds. So, and we got close to 25,000 messages per second per node throughput on our controlled benchmarks. So the CPU utilization was upwards 80%. Network not even close to saturating a 1 gigabyte network because our message sizes were pretty small. And on the storage side, right, the IO, again, it's completely a pluggable architecture. As we have decoupled these concerns. You can plug in or completely remove storage node or storage component from the KANDOLA node if you don't want to participate in storing blocks, just want to participate in consensus. So on the storage side, we actually the average latencies per block with 1,000 messages was around 40 odd milliseconds, per block, which includes around 512 byte messages of 1,000 and and the entire signature verification, leader verification, everything included, right? So all that was average was around 40 milliseconds. So that's the kind of throughputs that we can expect over even a very, very lean and thin infrastructure that we have for this demo. And,
yep. And the beauty of it is there is a huge song and dance going on between these three nodes, right? And because each one is sending each other control messages in a batch, it's making leaders making a batch of it. There's a lot of song and dance going on, but the beauty of the way it is implemented is it is leveraging every bit of juice that is on your CPU by making almost everything that can run asynchronously. So you're juicing out the concurrency and several of these verifications, not several, all of these verifications indeed.
Yeah, everything is async. Everything is async. Every line of code, as Gul called out, is tuned to max out the CPU / compute that you have on the consensus nodes themselves. And because we have completely decoupled the storage concern, we can extract the max out of the CPUs, and then we can delegate block storage to a completely different component which can do it at its own pace if required, or not hampering the throughputs that the network itself is achieving, right? So that's the beauty of it. And all this, right, even though we unfortunately we are unable to show all the observability, etc., we have extremely kind of insightful traceability built in. This is OpenTelemetry compliant. We have plugged into Jaeger, which can actually give you full trace end to end of all the component call hierarchies and call paths that your system has taken or the network has taken to process a particular message. And we are also plugged into because of OpenTelemetry, we are also on Prometheus. You can actually meter and monitor every single component call, method call inside your network node to the utmost granularity, including memory usage, latencies for IO ops, network ops, everything included, right? So unfortunately, we are not able to show the dashboards, but this whole stack is plugged in and it's integrated with OpenTelemetry. You can actually plug it into any OpenTelemetry compliant metering and monitoring system out there. But our implementation right now is tested against Agar and Prometheus. Gul, anything I missed?
No, I don't think so. You covered almost all of the pieces that stand out with respect to this prototype. I'd like to emphasize that this is the first step. I would have loved, and the entire team would have loved to share all of the sources and all of the work that we've done so far. That is our next step. We will get to it soon. We are right now in stealth mode, if I can say that. So we are not exposing the code yet, but we certainly will soon. And then I think we'll have a larger contribution from the community. So my apologies for keeping it in stealth mode for a bit more. And also, right now we're not launching this for public access. We're just demoing it on a case by case basis. So if you're interested in diving deeper, working with us, please reach out. Please reach out to all our channels, like Siddharth mentioned. And with this, let me give a big shout out to the entire team, Mohit, who did wonderfully on AWS, single-handedly, literally single-handedly, Fanish, who architected the system, and some kudos to me. I coded a little bit too, and the entire team and Nara, the head of research, and Siddharth.
Gul, sorry to interrupt you. One thing that we completely missed out, was this entire test network itself. The demo network itself has been brought up by Mohit, but the method that we have used is just out of the ordinary. It's completely automated. It's almost like one-click deploy on AWS. You can tear down the demo network, bring it back up in a matter of minutes with any kind of scale that you want over ECS. That's the whole reason that we went with containers. But Mohit has done a phenomenal job of completely automating it and living with the W3 philosophy, right? Easier deployment and decentralization, etc. Even the deployment actually embraces that philosophy.
Absolutely. I think every bit of work that has gone into this with such a small engineering team is just amazes me. So thank you so much, guys, and thank you so much, people who are interested and who are joining us today. I cannot be more excited for what lies ahead. I'll hand it over to Kriti and Siddharth to.
Nothing here. So what we had just witnessed is an end-to-end, fully secure, decentralized message delivery. A producer had sent messages to a consumer with no centralized entity in between. And the data ownership is with the producer and the consumer. So this is it may have appeared as a small step, but it's a very significant step that we have just witnessed. Those messages being sent and received. Our protocol is highly scalable, and we are extremely confident to have the infrastructure up and running to handle the throughput that is required for instant messaging for IoT. I just have goosebumps. Our team has been waiting, has been working really hard with coming up with all the ideas. What you've seen here is a snippet of all the innovations in cryptography, innovations in networking, innovations in decentralization, innovations in bringing in verifiability in the actions performed by every node of the whole network. So it's a sliver of all of that you saw here. So great work, Gul and Fanish and Mohit. I just have goosebumps.
Thank you so much, Nora. I'd like to close this and hand it over to Kriti for want of time. I'd like to maybe taunt Jack Dorsey a little bit, even if it feels a little bit too brazen to do that. I know Jack Dorsey a few months back and team at Block had mentioned that they're building Web 5, which is essentially what we've prototyped today and launched, sending messages from one entity, one address to another address in a very abstract, agnostic way, and that is scalable. While Jack Dorsey and team are slowly building this out, here we are.
Thank you, Aizen. Yeah, in continuation of what you just said, Gul, I think the construct of Web 5 is very similar. It's broken down in the context of decentralized web nodes and then a compute layer on top, which allows applications to build. And I think there is a lot more awareness now coming in that having the added complexity on layer ones itself is detrimental to scalability, is detrimental to compute. There's a tremendous amount of work spent by researchers, academia, by crypto startups on how do you ensure that smart contracts necessarily do not function the way they are right now. Excuse me, and the fact that they can be made much better. Energy conservation that's needed, much needed, I think, not only from a Web3 perspective, but from everybody's perspective. I think the amount of energy that's being spent on Web3, it's a shame that it's done that way. So there is a lot of optimizations that need to be done to make not only the systems more efficient, but also the entire compute more greener. And definitely it's our first step. I think there will be the notion of Web5s, the notion of what we are doing, real-time messaging, real-time data stores, all of them colluding to, let's say, the new version of Web3. But with that, Gul, I have a question, and that's something that has come up in the chat also. And I'm sorry, Kriti, I'm just stepping, going one step ahead. But this is also a question which I think I want to ask Gul and Fanish, which is our theoretical limits are close to 1 million on a 10 Gbps line, right? Or a 1 Gbps line. Correct me if I'm wrong.
1 Gbps. Our theoretical limits on the
it's 1 million or
it is 1 Gbps line. Correct.
Okay.
Absolutely.
On a 1 Gbps line, it's 1 million transactions per second. Now, what we are showing today, I understand that we are running on a very thin compute engine. We are running on vCPUs. It's not even like a bare metal. It's not even a GPU. But my question is, how much of scalability are we looking at here? What will it need for us to get to like 1 million, and when can everybody start seeing 1 million transactions being processed per second?
No, absolutely. I would not like to give an answer saying we are limited by infrastructure, which is an obvious answer. There is absolutely no limit to, if we had no limits on infrastructure, then everybody would reach close to 1 million transactions if they had the right algorithm. So, but coming back to your answer, I feel that the scalability of this can, even right now, even in the prototype, which is just the first step, it is not production ready, and that's why we call it prototype, right? So there are still a lot of algorithmic stuff that we can do to scale this. If today live, before I could move my mouse to the next tab, I can see 501 messages delivered. It speaks volumes about what achieved within the next few months to be able to. I'm very confident when we did the benchmarks with commodity hardware, we reached 150k plus transactions per second. If we did it right, I am fairly confident that on a good network between nodes, we should be able to reach 1 million messages per second pretty soon. Wait for our testnet.
Yeah, the other thing which I think was very interesting to see was the fast finality aspect of it, and the fact that the blocks were finalized instantaneously. There is no a 2 second, 10 second, 17 minutes or eternity wait for for blocks to happen. It is instant. So honestly, I'll echo what Nara said. Goosebumps. It's the beginning of many. I know the amount of time, hard work and effort that has gone behind the scenes. And just to let everybody know, we work out of 4 locations, 4 countries, 4 zones. So we have India, Australia, London, UK, and Dubai. And we work round the clock. So all of our schedules are synced or rather screwed. And Yeah, and just to give you an insight, as in we were up till like
for everyone to know that the core technology team have a cumulative experience of more than about 130 years.
yeah, that yeah, we've been coding.
It makes you
We've been coding
ancient.
for
But it's definitely something to note and throw a spotlight on. So I definitely wanted to do that. Again, want of time. One thing I want to set context of is we're probably going to run over. I know that we will. I want to make sure that we address a few more questions before we get into what the next steps are, NFT giveaways, etc., which is also on the agenda for today. As a quick pointer, I also want to let everyone know that we have a brand new shiny website along with our brand new shiny consensus protocol. So please make sure that you visit our website. And on the website, you'll see something called the industry section. I think referring back to a few questions that were asked today, right? Applicability. The applicability of this blockchain is going to be significantly more than the current DeFi scope. And what we're talking about is instant messaging. We have the ability to transfer message to message with verifiability, transparency, scalability. This means, just for reference, we're talking about food, understanding where your source of food comes from, so it's not just NFTs, it's not just gaming, it's not just instant messaging, it's smart agriculture, it's IoT, it's fashion technology, it's food technology. It is literally any domain that you can really think about at this point in time. So if you're thinking, where does Kandola fit in this entire ecosystem? Let me remind you what our tagline is. It is, Sid, do you want to share what our tagline is?
It's building blockchain inclusion for the next billion.
There you go. Building blockchain inclusion for the next billion. You heard it from us. We said it. And you'll hear more about it soon. I'm going to refer back to some of the questions that we've got. A couple more.
In terms of the our platform's use case, at least my personal favorite is this will lead to a decentralized data marketplace. You as a data producer will be able to own a data marketplace which you get to monetize. Your IoT data, video surveillance data is there for you to monetize. It's not owned by any other entity, and you don't have access to your data. You're the only person who has access to your data, and you decide what to do with it. So
absolutely. That is how to summarize applicability. So thank you for that, Nara. We've got a list of questions here. Sid, Gul, Nara, Panish, a couple of questions. We've already established why we are a layer one. So that's been addressed. We've talked about sustainability. We've talked a little bit about which league we're in and what it is that we're operating. We talked a little bit about TPS as well. How is Kandola better than ETH or Atom? So here we're talking about comparisons. Do any of you guys want to take a stab at that?
I can take a stab at it. I think first of all, I need to understand the question better. Is it ETH in terms of Ethereum or ETH as a token? Because then we're talking about use cases versus token values. But let me address it.
This is a question that's coming from Chanchal Sinha. Do you feel free to unmute yourself and ask the question if you want to? If not, we're assuming that it's not value, but it's the network itself.
Yeah, so Ethereum is primarily, as Gul mentioned, right? It's primarily a financial transaction system. It allows you to transfer ETH tokens from one point to the another. And on top of that, it has smart contracts. It allows you to do basic constructs. You cannot do a lot of complicated stuff on it. And essentially, because that's what is the limitation of smart contracts in itself. And it's extremely expensive, right? To do one transaction, you have to spend anywhere between $3 to $5, and the more complex your smart contract is, the even more expensive it gets. It has various limitations in terms of the maximum size of the block, what you can put it in the maximum size of the contract. So it's extremely the two architectures are very different, Chinchil, and what this is that we have broken down what the context of a layer one is. A layer one is not the one who should be allowed to do smart contracts, in our opinion, which is why we have smart contracts on top of a layer one, and it is built on a consensus of trusted execution environments, which allows it to run only once, not have to replicate across the entire network, and be blazingly fast and yet be completely decentralized. So verify the work, the compute, not necessarily the work. So that's a different discussion, and we'll get to that. So fundamentally, architecturally, there are very different from ETH, and from an economics point of view, we are a zero gas fee system. So the work done by all the nodes to come to a consensus is the same. It's a uniform block of work that everybody's doing, and hence the gas fees don't make sense. And you can look into a white paper to understand why it is the way that it is, and it's completely gas free, and it's way more efficient than ETH. We have a totally different economics in terms of the value accretion for the ETH. Value accreditation for a token. By the way, it's called Eka, which in Sanskrit means singularity or the beginning of the one. I think that answers the question. If not, Chanchal, please feel free to reach out to us on the community and post your questions. We'll be more than happy to answer in further detail.
We have another quick question. We're going to round it off with a couple more. This is the next one. Directing this question to Manish. It's coming from Didi. Is there a guide to node operation? Most test nodes are similar, but I want to know if it can be built using Ubuntu.
It can be built using any operating system. That's one of the thing, as in like design philosophies that we have followed, and even the packaging philosophy is to keep it extremely like platform neutral. We package it as Docker today, so it can be built on Ubuntu. I myself use Arch to build, and I have tried this on and Gul uses an M1 Mac to code. So we are already building this on different platforms as we speak. So there is nothing that stops you from doing development, running, as well as packaging this whole stack on any operating system that supports Docker today. Everything else is inside that. So you can actually run, develop anywhere you want. It's truly commodity. Nothing special required, no additional drivers required, no special libraries required. Just plain Docker, and you should be able to build everything from ground up on any platform of your choice.
Amazing.
We've also covered, there were a few questions. I'm sort of bucketing it. We talked about sustainability. We've covered that. There was another bucket of questions that were centered around, token release, token sale, and Ika, I'm going to direct that question to Sid. If you could also, as a part of, in response to that question, if you could also cover our roadmap. And where we see ourselves in the next 2 months, 6 months, and 1 year, that would be absolutely great. Any sort of forecast into the future.
Sure, absolutely. But what was the question around the tokens? You said.
Will you be releasing, your token? Does this project have a token sale? When will it be? Timelines, that sort of thing.
Yeah, absolutely. So we have our own native token. It's called Eka, as I said. The roadmap is to be able to complete our entire testnet, which will run for the foreseeable future. But the next 3 months is where we'll focus on 7 different use cases. The first will be CAN NFT, which is real-time NFTs that you can generate. These NFTs could be used by the news and media article. It could be for social platforms. Any content that you create on this platform becomes an instant NFT. So that's the first implementation. Then we'll have CAN Agri, as Kruti mentioned. This is for urban farming. They want to have traceability and transparency with their customers, so that the customers know what kind of produce they're getting. So there'll be an implementation of CAN Agri. Then there will be CAN Chat and CAN Mail, which is for social applications and enterprise communications. What happens when enterprise emails are leaked, and a good example is what's happening with Twitter and Elon Musk. So secure communications is something that has always plagued the industry. So secure enterprise communication, and also coming back to secure social communications, right? Whatever we send on socials today could be misused, have been misused. How do you secure that? So that will be CAN Chat and CAN Email. Then we'll have CAN IoT, which is the IoT implementation of how you can embed our the clients in IoT devices itself, not worry about the entire transmission. The producers will take care of sending the data securely over the network. Nobody can read your data. Secure, compliant with all IoT cybersecurity laws, and you get your data device to the rightful owner, and become the rightful way of information exchange on IoT. And then we'll have CAN Commerce, which is commerce implementation on ONDC, which is one of the world's largest pools of sellers and logistic providers in the world, 30 million, if my numbers are right. So that's something that will continue for the next 2 months, 2 to 3 months, and then we hit the main net, which will be either at the end of this year or early next year. We'll also time it based on the market conditions. And truth be told, I think good projects, regardless of the market conditions, will always have the right backing. We want to ensure that that we time it well. We are here for the long run, and that's something that I want to make sure that it's very clearly understood. We are here for the long run. We are going to transform the way Web3 is perceived, and more importantly, how Web3 is used. So it's going to be slow steps. So 3 more months before we get into mainnet. We'll do another round of private sale before that. Currently, we are doing a closed private rounds, but I think before we get into testnet, we would want to get the early community also involved with us. So we will do a private token with the community as well, involving the community as well before we get into mainnet. The entire community has been backing us from day one, so we want to ensure that whoever's backing us also gets rewarded. And then mainnet. So that's kind of the plan. And then we'll go list in public exchanges. So long answer to the question, but yeah, that's what it is.
Sorry, I was on mute. Super. Thank you. Thanks a lot for that, Sid. So we're going to get into wrapping up now. So just before we hit wrap up, I'm going to say congratulations to the whole team once again. This was phenomenal. KANDOLA Network has arrived on the global scene, and we couldn't have done it any better. So
I have to, there is I just want to again congratulate the team, and I can only, one quote comes to my mind during this time. It's a very small step for us, KANDOLA, but it's a giant leap for the distributed computing. That's borrowed from Mr. Neil Armstrong. That's what we are doing with this.
I was waiting for the one-liner from Sriram. It had to come. Sriram Baba has to give his blessings. That one-liner has to come from Sriram Baba. So thank you.
Thank you.
Without that we couldn't have ended this. Yeah.
With that, my next order of business is to actually thank all of our participants today. Honestly, we've been waiting to sort of share everything end to end, whatever it is that we presented today. We've been waiting to share it with all of you. And we know that, all of you will continue to support us and ask us and egg us forward or edge us forward to reach reach better heights. But as a token of our appreciation, for attending today's historic event, we are extremely excited to share that following vetting of a few criteria, if you've done the basics, which is follow us on all of our socials, make sure that you've probably socialized this with 3 more of your friends and you've attended this event today. If all 3 are a check, then I'm requesting you to fill up the Google form that has just been dropped in the chat screen, where we are asking for some of your details, including a very pertinent question, i.e. your wallet address. You will be receiving a very, very, a maiden historic NFT. A few months / a year from now, you're probably going to want to hodl one of 300. We're minting only 300 of these, and you want to make sure that you've got you're holding on to it. But we're going to be sharing that. So make sure that you fill the Google form, and we'll follow up and airdrop the details of the NFT to you. So there's just quick admin item. There's a terms and conditions. As long as you comply and everything's fine, then that's it. We'll simply airdrop the NFT to you. While we wrap up, Abhishek, if you can, if Abhishek, our chief lead designer, who has put on a very creative hat to come up with this design, which we all love, could you please share your screen and show our audience today their attendance NFT and something that they will be holding and cherishing for time to come. So while he brings that up, we just a quick point. Sid has already talked about testnet launch. Everything is in the next couple of months. Stay tuned. Follow our socials. Apart from filling up the Google form, you may also reach out to us on marketing@kandola.network in case you have any questions. You can also reach out to us at hello@kandola.network. All of our socials are available on our website. Please feel free to reach out to us through our website as well. You may follow all of us on our socials, our individual social handles as well. You'll find us, I'm sure. So that's pretty much out of the way. And with that, I'm going to hand it back to Captain of the ship, Sid. Do you have any closing remarks for us?
No, I think it's a wonderful job done. Thank you, Kriti, for a wonderful session that you arranged and for shaking, I think, the community up, making sure that they notice what we had to offer. A great thank you to the community who have come to join us. I think that means a lot. Years and months, I think it's close to a year since we started. We spent the first 10 months just working on the consensus. We got a paper peer-reviewed from professors throughout the world, CMU, Cornell, ISC, name the university. We've sent it to papers to everyone, collated feedback, worked on it, made it better. We still continue to work on it. We will. That's something that is always going to be a focus. And this is just the one from the many to come. It's just the beginning. So keep associated with us. I would say join our forums. Make sure that you have turned your notifications on for what we have to announce, and lots of interesting stuff to come. And we'll also share some funny bits in terms of the backend work that was happening just before the call, and how we just needed the time to get to the call. There will be another follow-up video that will come very soon in terms of behind the scenes. It was fun. It was intense past 2 weeks, I would say, but great job done. Great job done, and I think everybody who's taken out the time to come and join us and enjoy hopefully what we had to offer.